Hello students, now we are going to study about B trees. So B tree is same as a binary search tree. Then what is the difference between B tree and binary search tree? Binary search tree will be having only one value in each node. But B tree can have more than one value in each node. So these values are called as keys. Okay, so how many keys it can have? Each node can have how many keys? Each node, so for that it is associated with an integer t. So t is called a minimum degree. And also we have a formula. Each node can have t minus 1 keys minimum and a maximum of 2t minus 1 keys. So for example, if t equal to 2, then each node can have minimum of 2 minus 1, that is 1 key, and a maximum of 2t minus 1. So 2 into 2 is 4, 4 minus 1 is 3 keys. So if the value of t is 2, then each node can have minimum of 1 key and a maximum of 3 keys. And then next we are going to talk about the children. So how many children it can have? For that also we are having a formula. If it is having n keys in each node, then it must have n plus 1 children. But this is applicable only for the internal nodes, means non-leaf nodes, because as you know, leaf nodes doesn't have any children. So if it is having 2 keys, then it must have 3 children. So this is the rule regarding the children. And also, since it is a binary search tree, the left child must be lesser than the parent and the right child must be greater than the parent. So the same rule. So you can see here an example. So here it is having 2 keys. 2 keys means how many children? 3 children. Okay, so D and L, 2 keys and 3 children. And now if you see left A. So A is the left child of D. So A is lesser. So A is lesser than D. So it is a left child. And then if you take J, J is greater than D. So it is available right of D and it is less than L. So it is in the position left of L. And similarly S. So S is greater than D and L. So this is the rightmost child. So this is the property. So these are the properties of B trees. And now if t equal to 2, then already we have seen it will have minimum of 1 key and maximum of 3 keys. Suppose if t equal to 1, then we should not apply this formula t minus 1 to 2t minus 1 formula. We should not apply because this should be treated as a special case. So what is that special case means? It should be treated as a 2 to 3 tree. So this 2 to 3 tree already we have seen in the last lecture. So now we will study about this B tree and then next we will see how to insert. So how to insert, the insertion procedure or building a B tree. So how to insert a B tree? So for that also we have some set of rules or set of procedures. So what is the procedure? First you have to, if you want to create a new B tree, then you have to create an empty root node. So first you create an empty root node, then you have to insert the keys. Insert keys into the root. And as I told you, the keys must be sorted in ascending order. So when you are inserting the keys, how many keys you can insert? Because maximum of 2t minus 1 keys. So you have to insert keys until the root becomes full. Full means until it contains 2t minus 1 keys. Okay. So when it have 2t minus 1 keys, then what we have to do? So in this case, when the root or when any node becomes full, Then we have to follow some procedure. So what are the procedures means? See, what is the procedure means? What we have to do? First, we have to split the node. So how to split the node? We have to split the node around the middle key. So median. So you have to take the middle. You have to move the middle to the parent. So put the middle key into the parent. And then leave the smallest t minus 1 keys as an existing node, and then the greatest as a sibling of this node. So like that you have to split. Okay, suppose if the full node is a root node. If it is a non-root, then you can move it to the parent. If it is a root node, then you have to move the middle as a new parent. So you can see here an example. So you have A, D and L and you want to insert J. So if you want to insert J, so here T equal to 2. So there is no space. The root node is full. So what you have to do? You have to take the middle. So the middle is D. So move the middle up. And then move the middle up means this will be a new root. Okay, and then A will be the left and L will be the right. And now you can insert J also. So you are inserting in an ascending order. So J and then L. So D will be the root and then A will be the left child and J and L will be the right child. So this is the procedure for inserting. So now we will see one example. So we are going to insert the values from 1 to 10 into a B tree and the t value will be 2. So in exam point of view, this t value will be given in question. So just you have to apply the formula. So here t equal to 2 and we are going to insert 1 to 10. So how to insert? So first you will create an empty root node and you will insert 1. And then next you will insert 2 and you will insert 3. So empty node and then you will insert 1, 2, 3 root. And then next we are going to insert 4. So when you want to insert 4, there is no space because the node is full. Because how many keys maximum? 4 to t minus 1. So 4 minus 1 is 3. So 3 keys are allowed. Maximum of 3 keys are allowed. Already it is having 3 keys. So you cannot insert 4. So what you have to do before inserting, because here you have odd number of keys. So if you have odd number of keys, before inserting you move the middle. If you have even number of keys, then you may have a confusion which one is middle. So what you can do, if you have even number of keys, insert the new key and then move the middle. Okay, so now we have odd number of keys. So before inserting, move this middle. So this 2 is the middle one. So move this middle as a new root. And then left 2's left child will be 1 and then right child will be 3. So now you insert this 4. Okay, so this is the new B tree. Then next we are going to insert 5. So you can insert 5 because there is a space. Maximum 3 keys are allowed. So 5 can be added to this node. So it has added. Then next we are going to insert 6. So 6 here there is no space because maximum of 3 keys. So again what we have to do? So in this case we have to move the middle to the parent. Okay, so now 4, you have to move 4 to the parent and then split. So split 3 and then 5. So 3 is one child and then 5 is another child. So along with 5 you can add 6. So now 2 and 4 will be the root and then 1, 3 and then 5 and 6 will be the children. So simultaneously you can check the rule of number of children. So if it is having 1 key, then it must have 2 children. So here also 1 key, 2 children. Here it is having 2 keys, n keys means n plus 1 children. So 2 keys and then 3 children. So the rule is also satisfied. So 2 keys 2, 4 and then 3 children 1, 3, 5, 6. Okay. So next we are going to insert 7. So there is a space. Right side there is a space. You can insert 7. Then next we are going to insert 8. So if you want to insert 8, again there is no space because maximum keys are available. So you have to move the middle to the parent. So 6 will be coming with this node. Okay, so 2, 4, 6. So 3 keys will be coming here, and this node will be split. So you have to split this 5 as one child, and then 7 and then 8 as another child. So you can see here 2, 4, 6. 3 keys and then 4 children. So n keys, n plus 1 children. Then next we are going to insert 9. So just you can insert 9 here, and then so no problem because here there is a space. So just you can insert 9, and then next we are going to insert 10. So if you want to insert 10, so here there is no space. So what you have to do, you have to move the middle up. So what is the middle? The middle one is 8. So you have to move 8 to the parent. But when you move 8 to the parent, again here in the parent also there is no space. So what you have to do? You have to move this middle as a new root. So the same procedure can be applied as a recursive procedure. So this is like a recursive procedure. When we are trying to insert here, move the middle up to the parent, and again up if there is no space, and also this is a root. So you can move the middle up as a root. So now 4 will be the root, and then 2 will be the left child, and then 6 and 8 will be the right child. And then for this 2, because 1 key, it will have 2 children. So 1 and then 3. So these 2 children will be going for 2. And then here you have 8, you moved up. So 6, 8. So you have 6 and 8. So 2 keys. So it must have 3 children. So 5 is the leftmost child, and then 7 is the middle one, and then 9, and along with 9, 10 is also added. So this is the final B tree if you want to insert these values. Then we will have another example. So what is this example? We are going to insert 5, 3, 21, 9, 1, 13, 2, 7, 10, 12, 4, 8 and 11 into a B tree, and here also the B tree, the minimum degree will be 2. So 2 means minimum of 1 key and maximum of 3 keys. So now we are going to insert. So first you will insert 5. So you will create an empty node and you will insert 5. Then you want to insert 3. So with this root node, you will add 3, 5. So it should be in ascending order. So you should not write 5, 3. You must write 3, 5. All the keys must be sorted in ascending order. So 3, 5. And then next we want to insert 21. So 3, 5, 21. Because there is a space. Maximum 3 keys are allowed. And then next we are going to insert 9. So when you want to insert 9, here there is no space. So you have to move the middle up. So this 5 will become the new root. So 5 will be the root, and then 3 will be left, and then 21 will be right, and then along with 21 you can insert 9, and you have to follow the sorted order. So 9, 21. Then next we are going to insert 1. So it is a binary search tree. It is same as a binary search tree. So 1 is, so if you want to insert 1, you have to insert 1 compared with the root. So 1 is less than the root. So you have to go to left. So you will insert 1, 3. Okay, so along with this 3 you can insert 1. And then next we want to insert 13. So 13 you will compare with the root. So 13 is greater than the root. So you have to go to right. And then right you have 9 and then 21. So you have a space and you have to write 13 in the middle because the keys must be sorted in ascending order. So 9, 13 and then 21. Next we are going to insert 2. So 2 is lesser than 5. So it must go to left side. So left side there is a space. 1, 3. Only 2 keys are available. So just you can write 1, 2 and then 3. And then next we are going to insert 7. So when you want to insert 7, see again here with this, when you take 7, 7 is greater than 5, so it must go to right. So right side again there is no space because maximum 4 keys are available. So what we have to do? We have to move this 13 to the parent and then split. So move 13 to the parent. So you will get 5, 13 and then 9 will be the left and then 21 will become the right. So with this you can insert 9. So 5, 13 and then left will be 1, 2, 3 and the middle will be 9. So along with 9 you can insert 7. Then right side you can have 21. Then next we are going to insert 10. So 10, so what you have to do? So 10 you will compare with the root. So compare with 5. So 10 is greater than 5. Then so it will not come left side. Then compare with 13. So 10 is less than 13. So it must come in the middle. So along with the middle there is a space. So you can insert 7, 9 and then 10. So you can insert like this. Then next we are going to insert 12. So 12 again if you compare with this, what happened? 12 is greater than 5 and less than 13. So it should come in the middle. And in the middle again there is no space because the node is full. 3 keys it is having. So what you have to do? You have to move the middle to the parent. So just move 9 to the parent. So it becomes 5, 9 and then 13. Then 7 will be one child and then 10 will be another child. And along with 10 you can insert 12. So now you can see here 5, 9, 13. So 3 keys are available and it is having 4 children. So 1, 2, 3 is one child and then 7 is one child and then 10, 12 is another child and 21 is another child. So like this you have to insert. Then next we are going to insert 4. So with this tree we are going to insert 4. So where to insert 4? 4 is less than 5. So it must be inserted in the left. So you will come to left. So left already the node is full. 3 keys it is having. So what you have to do? You have to move the middle to the parent. So 2 is the middle one. So you have to move this middle to the parent. Again when you come to the parent, again here there is no space. So what you have to do? This is a root. So move this 9 as a new root. So move this 9 as a new root and then for 9, 5 will be the left child. Actually this 2 will also join. So 2, 5 will be the left child and then 13 will be the right child. So you will get like this. So 9 will be the root and then 2, 5 is the left child and then 13 is the right child. And for this, so when you take this 2, so what happened? When you bring this 2 up, then what happened? This 1 and then 3 will be, So when you move this 2 up and then this 1 and 3 will become the 2 children. So you can see here. So 2, 1 and then 3. So along with 3 you can insert 4. And then this 7 will be another child. So 2 keys and it is having 3 children. And then 13 is 1 key and it is having 2 children. So next we are going to insert 8. So where to insert 8? You will compare with the root 9. So it is lesser. So you will go to left and then you will compare with 2. It is greater. 8 is greater. So you will compare with 5 and 8 is greater than 5. So it has to go to right. So in the right side along with 7 you can insert 8 because there is a space. So you will insert like this. Then Next, we are going to insert 11. So, how to insert 11 with this? So, this is the B tree you have. In this B tree, you want to insert 11. So, where to insert 11? First, compare 11 with the root. So, it is greater. So, go to right. And then 11 is less than 13. So, you must go to left. And here in left, you have space because you have only 2 keys. So, you can write 10, 11 and then 12. So, you will get like this. So like this you have to insert all the values, and this is the final B tree after you insert all these values. Next, so that's all about this example. Next we are going to see another example. So this example is very simple. So here the same values you have, but t equal to 1. So t equal to 1 means you should not apply this formula. It is a special case. It must be treated as a 2 to 3 tree, which already we have seen in the last lecture. So just I will show you the final example. So I will not give you the step by step. So these are some steps, and then this is the final tree you will get. Okay. Then next we are going to see another example of inserting. So here already there is a B tree. In this B tree you are going to insert one value. So here see here the value of t is 3. So the value of t is 3 means it can have minimum of 2 keys and a maximum of 2 into 3 minus 1. So 6 minus 1, 5 keys. So minimum of 2 keys and a maximum of 5 keys. So now we are going to insert 2. So where to insert 2? So here 2 is less than all the values. So it must come to left. So left, maximum how many keys are allowed here? 5 keys. 6 minus 1 is 5. So 5 keys are allowed. So here there is a space. So just you will write 2 along with this child. So 1, 2, 3, 4, 5 you will get. Then next we are going to insert 17 into this tree. So how to insert, where to insert 17? So first you will compare with 7, 17 is greater. Then you will compare with 13, 17 is greater. So you will compare with 16, and again 17 is greater. So you will compare with 23. So now 17 is lesser. So it must come between 16 and 23. So here you must insert. Okay, so here you must insert 17. So in this child, you have to, in this node, you have to insert 17. So this node already having 5 keys. So it is full. So what we have to do? Again, we have to follow the same procedure. So it is having odd number of keys, and hence before inserting, move the middle to the parent. So move 20 to the parent. Okay. So here in 20 you have to write the order, same order, add 20 and follow the order. So 7, 13, 16, 20 and then 23, and divide this. Okay, divide this node into 2 children. Okay, so 18 and 19 will be one node, and then 21 and 22 will be another node. So now along with this 18 and 19 you can insert 17. So this is about, so that's all about inserting B tree. Okay, so if you have any doubts you can ask me.